Um, I'll jump right in here since we're running just a little bit behind, but this is metaprogramming in Ruby, and we're doing it wrong. So welcome and thanks for having me. If anybody wants to follow along, there's some slides online if something's not clear up here, but I'm trying to prepare as much as possible. I'm Ken Toler. I do application security at OnDeck. It's financial services, small business lending type of deal. I work in Ruby, Java, Node, .NET, all the above. I have a little bit of a consulting background before I went there, but I know that this is like the short part of the talk. Nobody actually cares. I guess starting off with this talk, just to give you a little bit of an overview of what we're going to be going through. Can I get a general idea of like who is actually in the? I mean, do we have Ruby programmers in the room at all? Just a couple. And of that, how many are familiar with the concept of metaprogramming? A couple. Okay, cool. Perfect. I wore my Stranger Things shirt today. There's a reason for that. We're going to be getting into trouble with the 3 deadly sins in metaprogramming. We're going to go over some Ruby. We're going to break some stuff, fix some stuff, do all that. But more importantly, I did this talk 2 years ago. The reason I'm bringing it back up is because the same problems still kind of exist. The big thing I want to cover is I won't be going through any of the live demo today because I'm going to avoid the Demogorgon. No? Nobody? Oh, come on. There we go. I got one back there. So what is Ruby? Ruby's this is the basic textbook definition of what Ruby is. Dynamic open source programming language with a focus in simplicity and productivity. I've heard a lot of people dog on Ruby today. I'm sorry. I like it. It's great. The reason is that, things like this is a really simple implementation of something. You can create this greeter class. It's really readable. For me, without a computer science background before I got into security on the whole, it was really nice for me to come into a language that allowed me to get things done. And that's why I fell in love with Ruby as my first language to get stuff out the door and when it came to doing security stuff. So what's best in Ruby, right? The big things that are best in Ruby are it's elegant, simple, and productive. Those are the big things that I like. I don't like having a lot of what I consider extra stuff when I'm trying to get things out the door. I'm not an enterprise developer. I just want to get something done. As a result of it being easy to deploy, of these gems coming in and kind of rushing me out the door, I shoot myself in the foot a lot, and it makes it really easy for us to do that. And what is metaprogramming? When I first found out about metaprogramming, the definition that was given to me was code that writes code. And I was like, that sounds like magic. That's awesome. It sounds like an AI, right? But what the more accurate definition is code that manipulates language constructs at runtime. It is not AI. It is not magic. It probably opens up more problems than we would like, and that's what we want to draw attention to, right? One of the most common examples is this concept of Rails dynamic finders. Are folks familiar with the concept of a ghost method? Okay, so ghost methods are these are kind of set. They set you up, right? They set you up for success. Basically, Rails has this concept of a ghost method in find by and kind of an active record where it takes the tail end of a method that you have, throws it in, says, hey, that looks like something that I can find things on in the database in my persistence layer, does some stuff, looks for the condition, and returns them. So that way, the cool thing about the metaprogramming part of this is that as long as I can create an attribute that is as part of one of my database objects, I can find on it. I don't have to write any new code. I don't have to put anything else in the controller. It just works, right? It's that Rails magic that makes it really easy for folks to get up and running and to get these programs out the door. That's what it looks like, and if we have time, I will try to get into it in the tail end of the talk. So what are the 3 deadly metaprogramming sins? The first is send, the second is constantize, and the third is eval. I won't spend too much time on eval. I think we know why eval is a bad thing, but I'll touch on it. So send is, this is again the textbook definition. It invokes the method identified by symbol passing in any argument specified. What that really boils down to is that if I were to call test.length on a string, it's essentially equal to test.send, the symbol length. It'll return the length of that string. So why would we even use this, right? The biggest things are it dynamically lets me decide what method to call. There's some debate on why or if it should allow us to call private methods, but last time I checked, it still did. Most importantly, it lets you decide what to call at runtime. And you might say, well, why would I want to even go down that road? It's really valuable in testing. It's really valuable in if you want to limit the amount of code that you are putting inside of the code base. So this is a little bit of an example that I wrote up in a demo application that I have these videos for to avoid the Demogorgon. But the actual live code is available, and you can spin the application up and play with it if you'd like. But this is the method that's in there. Basically, are finding an employee, we're passing it a type. That type is essentially a name or a status. We're sending that directly to a string value, providing with a value and saving the record. The cool thing about this is no matter how many types I add, I just add the type in the model or in the object, and this controller method will still function. And I don't have to write any additional code. So with 5 lines of code, I've set myself up for the future, which is, from a functional standpoint, great. So this is what it looks like in the view. I sped these up to try to cut down on the time. But I'm changing my name, I'm changing my status. That's essentially the idea here. Obviously, if we are just trusting the view to do our security, we're going to get into some trouble. But the real cool things about this are that we have achieved functionality for 2 types with minimal lines of code. I've only had to write this 1 time. I've added new types of object attributes without having to rewrite the controller, meaning that I can have name, status. If I wanted to give access to the salary, I could, things of that nature. And if I wanted to add any actions in the future, I could do that as well. Another really cool use of this is things like this. If I have a configuration of IDs and secrets and URLs and database strings and things of that nature inside of a configuration file that I throw at an application, I don't have to write these in the code. I can load them dynamically in this way. You may have seen something like this second piece here, where you can load it from a file, but you're still calling those variables down the line of that particular module. You can still load the file, but you're still putting all that inside of the code. And if you make a change, you have to make a code change. With something like send, you can run it through the loop, and all you have to change is your configuration file. So depending on what deployment you go to, whether it's production, development, staging, whatever, you have a 5-line loop that goes through every key value pair inside of that configuration, whether it changes across staging, production, or development, and you have what you need in that same 5 lines of code, and you don't have to go back and change it in every single environment configuration. The bad things here are that it obviously lets the user determine what method is called, and it allows the user or attacker to take advantage of method developer may not have intended. And in the demo here, we throw Bob in there. We say, hey Bob, I don't want to send you a name. I want to send you a new salary. I'm going to set the salary to $12 million or something ridiculous. And then even though I haven't exposed that on the front end, I'm able to get that salary changed in the actual view. And there we go. So now we have $12 million. The other thing is that it gives you access to things like ID, every instance method that's instantiated. So when you're sending these, you're not just exposing attributes of the model, you're exposing pretty much everything for that particular user. In this case, I'm changing the ID value in better applications that might give me some vertical privilege escalation or something along those lines. In my application, it just breaks everything. These are all the instance methods that you expose in something like that. Basically what I've done is anything that can be assigned a value, I've pulled out of this. And so if you can do something crazy with these methods, then you can experiment with that, but you've exposed essentially all of these with send, if you're accepting user parameters that way. So what's the fix? The fix is to avoid using user controllable parameters with something like send, because it is a powerful use case, and it's really awesome to use in those configuration contexts or in unit tests or whatever it might be. But when you're accepting user controllable parameters, it can kind of shoot you. If you have to use it, maybe whitelist or find a way to limit the number of methods that are callable. In my case, for the stopgap for the patch would be just to put a list of acceptable params that functions similar to like a permit function, and then you could always use dot notation like we saw in the beginning of this particular section. The next one up is constantize. So constantize is interesting. Again, the textbook definition is tries to find a declared constant with the name specified in the string and returns that constant. The name error comes when it's not in camel case, the string's not in camel case, or if it's not an initialized constant. So here is an example of how we might use that. And this is kind of a reduced, kind of a dumbed down version of something that was actually found in an open source project in GitHub. But basically what's happening is a class is being created. It's running constantize to say, hey, is this a constant? Is this an object? And then it's running the find by. So it's using it as a validation method. So why would we use it? Again, great for unit tests and reducing code. So I can essentially validate whether the constant exists. I can reduce the code that I write to test those all of my classes and all of my objects, and I can write at one time. In this particular instance, we're using it to validate employee IDs as a demo. So it just kind of brings up the employee ID and says that's a good ID. If it doesn't, it'll error out, and I should catch an exception. Again, what we're doing is minimal lines of code. We can use that same controller that I have listed here to function across multiple classes. I could do it for employees, I could do it for reports, I could do it for contracts, and all of those are inside the database in the demo app. I can run the same unit test on all of those classes, and again, it's 4 or 5 lines of code. Bad things are, it allows the user to essentially run it on any class. So if you haven't considered what classes you have or what objects you have in the database, then you could get into trouble there. It allows the attacker to footprint the application when name error is returned. So if you're not catching your errors properly, and they could use this in kind of a brute force attack to do it, and I have a demo for that. If errors are called, the attacker could obtain sensitive information if you're not handling those properly. So here is the concept of, I'll just change the class that I'm using. You guys probably can't see that, but I'm changing it to user, and instead of validating an employee, it's bringing me back to the first user in the database, which obviously could be a privileged user, an admin, give me some escalation privileges there. In the second example here, I've got an attack going. Essentially, there's 5 values here that are 2 are the employee and user that we saw. 1 is report, and 2 are just junk ones. And you can see from the length of the response that 1 is not like the other. So the 2 200s are the employee and the user that I can obviously validate and see. The 2 apple and not an apple return the name error, because that's what constantize will return if it's not in camel case and not an initialized constant. But the last one is a no method error, meaning that it was an initialized constant, but it didn't have some attribute. In this case, it was a report and didn't have an email attribute. And so as a result, I can see that is a valid database object that I could probably use in another attack. This is no longer live code, but it was pulled out of an open source project in GitHub. And I felt like it was necessary to show you how this is actually used and that this stuff actually exists. I'm not making it up, and it's not just demo applications. So if you look at this method, basically what's happening is a payment method is being created. The parameter that's coming in is something like credit card or gift card. The type is something like MasterCard, Visa, or something along those lines. And then we just are accepting a bunch of parameters in to create the object. You see the object gets placed with all of the parameters, and then it just saved and goes through the callback side. So if I were to pass a payment method in of user, regardless of whether Visa, MasterCard, or whatever is in there, it deletes the type value, constantizes it, and then I could create a user off of that. So this could be used as a possible way to create users using some other endpoint, which is a pretty interesting find inside of GitHub. So what's the fix? Same kind of stuff. Whitelist if you can. Constantize does have the ability to make reference to all the initialized constants that are in there. So if you do take user parameters there, then you could get into some real trouble. So just be aware of what your models are and where you're accepting those parameters and whether you need to whitelist or do some other form of changing there. In this case, we whitelisted. That way we can maintain that particular list maybe in a file or in another variable or an array or something that I provide locally. That's what that looks like. The last thing is eval. I will try to blow through these. Eval, obviously, it's executing Ruby code. And I don't want folks to be like, oh, it's eval, we never use eval. It does get used, and it is in some of these open source projects. But let's think of why we might want to use eval. And I thought on this for a while when I first put this talk together, and it was kind of like, well, obviously we want to run all the code, right? And so if you're a new developer, why would you want to do that? Well, I can dynamically run it, and I can create Ruby environments, and if I wanted to teach someone Ruby, I could do it here, and I have to sandbox it, and I don't want to limit the amount of functionality that they have. And I was like, okay, that makes sense. We're pulling out all this stuff so that we can train people on Ruby, but you still want to kind of protect what you're doing. But the interesting thing, and I guess the one example that I found that made more sense was something like this, where instead of having the knowledge of how Rails routes work, someone created this method of passing or created this profile show page by taking the class that exists and doing it all in one line of code. So basically, no matter what object I have, I give it an ID, and it returns the name, which, logically makes sense. And they were like, oh, it looks really cool. It's one line of code, and I basically have a show page for every single one of my objects. And that's a real example. And that's the one that I put in here for that reason. I had to take a step back and kind of realize that it is actually kind of cool that you did that all in one line of code, but you opened yourself up to a whole lot more. So we kind of have to think about that. And you have to realize that you are opening it up to any Ruby code. So if we did have to do that in the case of something like a code training site or something along those lines, how could we do it? Here's an example of kind of what we did with that as a demonstration. We can change employee to user like we did with constantize and send. We can also do the arithmetic operations in here. We can see when something is not found. We can generate errors, and ultimately at the end of this video, we exit the system. And if you don't have any recovery options there, you can just crash the app. This kind of shows, if you don't provide it with a value, then it won't execute just because of the logic on the back end, but ultimately we run a system exit. So what's the fix? Avoid using eval as much as possible, pretty much altogether. And the only use case that I've been able to think of is kind of the sandboxing environment. So if you were going to do something like that, maybe spin it up in Docker or some container you don't care about that sits off under the application that doesn't relate to the parent application. Even throw in an iframe or something. Just to get it out of if it does crash or if they are pulling information out of it that it's not sensitive. But honestly, avoid it altogether. The last thing is method missing. So I talked a little bit about this with the ghost methods and everything, and I tried to simplify it a little bit so that it made some sense. But essentially, you can override method missing. Method missing is a method that gets called when when it doesn't understand what it's getting. When the method is missing, it runs this method. You might want to use it if you wanted to do something more intelligent. In the case of active record or active model, you can dynamically create methods on the fly in the same way with the regex, and kind of have a pattern that you want to create. And this is a simplified version of what we saw in the first part in active record. It basically takes the method. If it has find by in the method name with an underscore at the end, it takes that tail end and uses it as an argument to find information based on that. It also allows the attacker to create any method attached to find by, so they could find by role or whatever it might be. So it's, again, just important to understand the implementation there and make sure that when we are accepting user parameters that we consider where they're being accepted and how. The fix is basically just to avoid giving that power to users altogether if you can. Reserve it for development, back-end services. If you do redefine method missing, make sure that you're calling super to the actual method missing so that it has some place to go if it errors out. If it can be avoided, avoid it, but otherwise just it takes some heavy consideration. So this is the interesting part. These were the results from 2 years ago. basically with send, only kind of isolating send inside of just application controllers, we had 877 results. Some of those might be people just putting up test applications or whatever it might be. Same thing with contentize, taking direct user parameters into the app controller's path, 7,652, and eval in the app controller's path, 422. With send, we went from 877 2 years ago to 1,547 today. So that is still an issue. With constatize, inside of the app controller's path, we went from 7,652 code results to 12,639. So this problem is kind of exponentially growing. The only thing that really crept, was eval, thankfully, kind of at 561 results. And out of all of them, I guess I'm kind of happy to see that. I mean, obviously there's going to be more code on GitHub now than there was before, but constatize was definitely surprising there. There might be a way to see if these are being pulled out or sanitized in some other way down the line, but honestly, it's kind of, I'd really be interested to dig into this a little bit further. I think that's going to be the next step here. So I'm not poo-pooing on Ruby. I do love Ruby. For the people that do like Ruby, the two of you in the room, it was my first language, so I do understand that it's easy to use and shoot yourself in the foot. But I just kind of want to harp on the importance of implementation here across the board, and to always think about the attacker as you're implementing any kind of language. And that's it. If you have any questions, I am open. If we're running okay on time, which it seems, maybe, yeah. And the code is available on this link, and you can tweet me there at Rolotnik. Questions? What's up?
You might have said this, I missed it. For the send functionality, can it only call methods of that type of object, or can it call parent?
It can call anything that is an instance method of that particular object, which I'm actually not 100% sure. We can look at it. We'll just run it through and find out. But if you open up ERB, you can see everything that's able to be called. You might be able to pump up the stack. I'm not sure. Let's take a look afterwards.
I have another question.
Yeah.
In terms of finding this blind, are you typically only finding this through source code review, or do you have certain processes you're using to find it blind ways?
Most of this, actually, I would say 90% of this is through source code review, because especially with send, constatize, and eval, I always hit those in a Rails review, because if I find them in the app, in the controllers, then there's a good chance that the sanitization is not happening, and that's usually how I find it. As far as dynamically, I don't think that I found these particular issues related specifically to metaprogramming myself on the app dynamically. But usually my engagements have some kind of static component. So, anything else? Cool. Well, thanks again for coming to the Stable Talk after 5. Appreciate it.